Hello guys, another talk about vintage machines. Today we discuss being old, not being a fatality, and the denial of age. So in this series, if you guys noticed, I'm putting myself in the shoes of a factory leader or a manufacturing owner and trying to understand what are the ideas or maybe the psychological background that is behind our decisions. Of course, there's a lot of things related to technical background, but I have the feeling that let's say the leadership piece or the psychology piece has more impact on the decision. So we're exploring that, trying to also make the parallel between machines and human beings, because you will see that with the modern culture, there are a lot of parallels, especially today with our topic, like being old is not a fatality. You can apply it to a machine, but you can also apply it to a person. So let's discuss it. Let me check quickly the sounds. If you guys hear me well, let me know. We are live. All right, seems to be good. So let's continue. And for those of you who are just joining after lunch, it's normal because I've decided to switch to that slot in the afternoon. We will see if that fits better for the audience and maybe for you guys who are not available in the evening. We'll see. So topic of today, the age or how old machines can become a fatality for some people. What I'll try to do, as last time, I'll try to do a little sketch so that it makes it more interactive. And if you want me to develop something, we will discuss four aspects of this topic, but if you want me to develop something, let me know. So we'll talk about performance, right? Why we always have this kind of injunction to be like to have high performance. Then we will talk about consumable and being disposable, right? Then the cycles which are accelerating and how that involves age, and also the let's say we want all the machines to be versatile, but compared to today's trends, now we're more discussing about specialized tools or specialized technology. So we'll compare that being versatile versus being specialized. So that's the menu for today, and let's start right now with the first topic. It's really an open and freestyle discussion, so if there's anything you want to add, don't hesitate. I also like it because it makes like a little break in my week. So as I told some of you, this channel is also a way for me to like enjoy and share passion. So we can be totally like freestyle and transparent if you guys have some comments. So the first aspect of this topic about age is the injunction of performance. So we want to be to perform, we want to be like useful, we want our machines to have impact, but let's question that aspect, like performance, because what makes age a fatality sometimes is this need or this obligation to have top performance all the time, and we all know that this is not possible, even for on a, let's say, human point of view. You know, we are all physically limited, and it's even more true when we discuss about machines which are working with energy, consumables, supply, etc. So there is for sure like performance is degrading over time, but does it mean that this degradation of performance or this age becomes a fatality, right? And even sometimes people will try to deny this aging of their machine or this aging of themselves. As I told you, like this can be applicable to persons as well as machines. But denying the aging of the machine, sometimes it hides some kind of shame of not being top performance or not being useful, not being essential. So the keywords here are, what does it mean to be useful in terms of machinery, right? And what does it mean to be essential piece of machinery? I'll give you one example. At Autumn, we were working for a steel factory. They are like doing custom steel work for like very special clients. They will come with a specific need, and depending on what the clients want, they will use a different set of machines. They have plenty of them. So depending on the type of cutting on the steel, or depending on the type of steel that they need to use, do they need to bend it afterwards? Do they need to weld it after? So this kind of mechanical workshop, you know, but around steel. And in these kind of processes, because the need is specific to the client's request, we will have some type of machines, and that was the machine we were working on, which is used, let's say, overall, maybe 2 months in a year, if you sum up all the runtime. And if you use that machine 2 months per year, of course, you will see that for the rest of the year, either you will need a lot of maintenance to keep the machine running, or if you don't do that, the machine will, you know, over time, it will start, you know, having more breakdowns because of wear, because of many things. So, and the aging of this machine, these kind of machines which are not used so frequently, the aging is accelerated. And that means, should that machine be considered as not performant because it's running just 2 months per year because it's aging rapidly? And of course, in the case of that client, the answer was no, because they needed that machine to keep operating for those specific needs of their clients. So this was just an example to say that, you know, the aging of the machine, even though it can reduce the performance, it doesn't make the machine obsolete, you know. So every single process, every single line or machine needs to be assessed and, you know, evaluated one by one. But definitely, like, we need to avoid this bias around performance. Otherwise, we can miss some important machines that were, you know, cornerstone in our process. For instance, you have machines that are the only one which can do some high-end products, and even though you use those machines just once every one and then, you definitely need to maintain the performance of that machine. And even if they are old, you still need them. So usefulness, you know, is relative, and we need to discuss it one by one depending on the machine. So that was the first topic about the injunction of performance. Then, second thing, if I were a manufacturing leader and I had to decide about age of my machine, there's something that I'll definitely discuss. It's the let's say consumable aspects. You know, sometimes because the machine is old, we consider it as disposable, you know. And we all know that normally a consumable is just like components that we use in our manufacturing process, but sometimes the machine itself becomes disposable because it's old. it becomes disposable because it's old. And that's another bias. Let's say I have like my I have my equipment which have been there in the factory for 30, 20, 10, even 10 years. And now I have new pieces of equipment because, I don't know, we got a budget for investing in new machines. We consider that the machines that we can dispose, which we can throw away, are the ones which are old. And sometimes that's not true. First of all, because sometimes the old machines have the same performances than the new ones, but also because maybe they will have some pieces of equipment which are really new, and over a period of time of few weeks, they become also they start having bad performance. And if we were to classify the Pareto classification, the ABC classification, if we were to classify in terms of which machine we need to focus on and which ones we need to start replacing, you will be surprised that even some new machines can fit with those criteria. Like if the idea is to replace something, the first criteria shouldn't be just the age, because even new machines should be replaced. Some of them, not all of them, but some of them, it can happen that they become, can be or can fit with the criteria of replacement. Let's put it that way, with criteria of replacement. So if I were to analyze, like, okay, I need to assess which machine I need to replace, in my case, I will not start with age. Maybe I will put in place a matrix that involves many different aspects related to process, related to the product, related to the skill of the people using the machine, but definitely not age. That was the second part, being consumable. If we consider age as an eligible criteria for being replaced, definitely we can miss some opportunities. Then the third part about let's say the technology cycle. We all know that compared to the past, technology cycles are accelerating. Maybe for one reason, there are multiple reasons, but one reason that I see is that now technology is driven by software, and in the past it was driven by hardware. So nowadays, software is leading the pace, basically, and if we want to follow the same pace as software, we can also make a mistake, because normally a machine, if we take the criteria of just like depreciation, normally a machine is supposed to be depreciated in like 20, 30 years, which is totally different from the depreciation period of a software. Software, normally over 1 or 2 years maximum, you're supposed to have like depreciated it, or after 2-3 years, you will have another cycle bringing a new software solution which is better than the old one, which is okay. I mean, it's understandable. Processing power and computing is progressing. So for software, I can agree that, okay, every 3 years, the new technology that will come out for the market can be, or usually it's the case, it's better than the old one, even though you will have some nuances, some cases where it's not true. But for software, it can be true that the new software is always, or most of the case, better than the old one. But for hardware, we need to be like very specific when we discuss the life cycle of a machine, because You will have some electronic cards inside that machine, which might be deprecated. I mean, in terms of maintenance or the vendor support, they might not be supported anymore. But it's not because one electronic card inside the machine is not supported and that the whole machine is totally obsolete. So for hardware, it's more complex, I would say. It's definitely more complicated. That's why it makes it a little bit harder when we are maintaining a fleet of machines instead of just maintaining an IT infrastructure, because when it's hardware maintenance, we need to really open the box on each specific piece of equipment and understand what is inside, what's the breakdown of the machine, which parts are at risk and which other parts can still be used, with the same level of robustness without changing performance, etc. So it's more complex, and very important to understand complexity among when we're dealing with technology cycles. Again, just to avoid mistakes or missing some opportunities, we need to embrace complexity. Not everything is as simple as IT, even though those IT guys are leading the world right now, the Silicon Valley and everything. But when we're discussing with hardware, it's a little bit more complex, but that's also what makes the beauty of hardware. So yeah, technology cycles, also another important topic when we're discussing with age. And fourth topic and last one, why age shouldn't be a fatality for your machine. Because in the good old times, the machines were built with some kind of versatility. I hope I'm pronouncing that word right. Versatility. Fine. As opposed to hyper-specialization. So some systems right now, I mean, in the modern design, we want them to use like very specialized components, instead of having like a splitted set of components. People will request in their standards that we want to use, plug and play components. That's let's put it that way. I would put on that side the old design and the new design. So in the old time, how was it? Old design. We were using some diversity of components, right? Diversity of electronic cards, diversity of, let's say, even the, so electronic, mechanical, even some softwares, operating systems, right? We agreed on using many components as far as they are mastered. So the most important piece when dealing with some old machine is that people wanted something that they knew, right? Something they knew, because they wanted a match with the skills of the designer and the actual skills of the maintenance team. So it was all centered around skills. So for the designer and for maintenance. Right. Now, in the modern design, what I see, if I should make a comparison, in our modern time, we want standard components. We also want plug and play systems, even if it's a black box. What's important is the time to market, right? So we agree on having something which is a black box, but which reduce the time to market. And that's what we see right now, just one example dated from yesterday, right? We were discussing with the clients, and they have in their system, it's a logistics system, a box which is used to make protocol conversion between one part of the system and the second part of the system. This box was ordered from an external person who developed it, but they don't have the source code. The thing has been running in production for more than 3 years now, but no one knows how to maintain it. If someday it breaks, they will have to replace it or redo it, which is a problem. But their issue, why they accepted this black box, is because they had pressure from leadership, maybe, or just from project management to deliver in time. So the time to market, again, was more important than the maintainability of the system. So this context of speeding up the time to market, having something hyper specialized, hyper standardized, that's what creates the fatality of age. And if we really want to avoid it, not seeing age as a fatality, we need to make sure that our systems are versatile. I don't say that everything that we were doing in the past was 100% perfect. Of course, like having a diversity of components inside just one machine, it creates more problems in terms of skills. Skill set needs to be higher, which is a big problem nowadays, because we don't have the time to train everyone on all kind of equipment. Fine, but at least in the past, those components, that choice of component was made according to the skill set of the maintenance, according to the skill set of the design, and that was the trend that we can take inspiration from and try to apply it in our modern systems. Right. So I think that was it for what I wanted to share. Performance, consumable, the accelerating cycles, and also this aspect of versatility. Let me know what you guys think. I think I will continue to explore these open discussions about psychology, vintage machines, the human aspect of things, because I really think that's where we have leverage. That's where we make the difference, instead of just speaking about technology. I think we have talked a lot about technology, so now it's time to address some more human-centered aspects. Right. Thanks for listening. Thanks for watching. For those of you who will see it later, and I wish you a beautiful week.